Hello and a very good day. We are Group 9 from Section 2. We will be presenting our application of numerical mathematics in civil engineering area. I am Rukaya Al-Qudsiyah, will be covering Chapter 1. My group member Nurul Anisa will be covering Chapter 2, Umi Hafsah covering Chapter 3, and Muhammad Akil Azlan covering Chapter 4 and 5. This study undertakes a comprehensive exploration focused on the determination of the surface area for the construction and waterproofing of swimming pools characterized by irregular shapes. The project advocates for the strategic application of epoxy coating materials, emphasizing the importance of achieving optimal coverage on the pool's concrete surface. Thus, calculation outlines a methodical process involving the tracing of the irregular pool based under a scale graph employing Simpson's rule of 1/3. The absence of a systematic approach to calculate irregular pool bases can lead to inaccuracies, hindering precise estimation of material requirements, particularly in the application of epoxy coatings. Consequently, this knowledge gap raises concerns about potential issues such as poor coating, water seepage, and structural instability, necessitating a focused investigation into an effective and accurate methodology for assessing the surface area of irregularly shaped swimming pools. The objectives of this study are to develop a systematic methodology for calculating the surface area of swimming pools with irregular shapes, to assess the precision and reliability of the proposed methodology, and to propose practical solutions for optimizing epoxy coating materials.
Hi, my name is Nurul Anisa, so I will present the literature review of our project. For the swimming pool need waterproofing planning to prevent water infiltration and structural damage. So that we need to evaluate the durability, effectiveness, and performance over time. We need to focus on sustainability with eco-friendly materials and energy-efficient system. For the second point is waterproofing epoxy coating. Epoxy coating known for high adhesion strength, chemical resistance, and impermeability. Our analyses are to assess the durability and performance of epoxy coating under various stress. So that we need to find the best application technique and coverage in waterproofing technologies.
Hi, my name is Umi Hafsah binti Muhammad Zaini, and I'm going to present the methodology part. In this chapter, in this project, we need to analyze the numerical application to determine the surface area of irregular swimming pool. We use the meter square, and by that we can estimate that how many kilos of waterproofing epoxy that can we order for them to coat the swimming pool base. So now we move to the calculation of the numerical application. Firstly, we need to use the trapezoidal rule application. As the interval gap was given, so we need to determine the step size and equal with the B minus A. B is the upper limit, U minus with the lower limit. You need to divide with the H. And after you get the answer, if the step size is you can multiply with the 2, then you can use the Simpson rule 1/3. And after that, usually to find the function value, we need to tabulate the calculation using this calculator, and it will automatically give the answer. But in this project, the function value was given, so it is easier for us. We just need to separate the function value by the column of the table, which are initial and odd and even. We need to separate it based on the iteration. If the iteration number is 0, 1, 3, we need to, the 0 is the initial. So for the 1, 3, 5 and so on, we need to put in the odd value. So after that, as the value we get it, then we need to total the function value, and after that we need to put the general of the Simpson rule 1/3, which is I you equal with the h per 3 multiply with y0 plus yn, and plus with the 4 we need to multiply with the sum of the odd value, and plus 2 we need to multiply with the sum of the even value. To find this formula, we need to find the area of the swimming pool base, and this formula is the fixed one. To determine the total pool wall, we need to multiply the parameter of the swimming pool and the height of pool depth. And after that, as the total pool base was tabulate and also the surface area pool wall tabulate, we need to add these two values, in order for us to find the total surface area of swimming pools. And the last step, as the Nippon Paint catalog that we provided in this project, it is that the rate of waterproofing material per surface area was given, which is 1.0 kilogram per meter square. So we can order the waterproofing epoxy in kilos, which is to find this, to order this, we need to calculate the total area pool base multiply with the rate of waterproofing material per surface area. For the filler table, for the facts, we need to obtain base of the swimming pools and also the surface area before applying to the waterproof coated of irregular swimming pools. And we also can find the kilos of the waterproofing epoxy. And for the ideas, we need to determine the surface area of irregular swimming pool, and also we can determine the amount of waterproofing needed from aspect how many kilos needed to cover the swimming pool base, the surface area. So for the linear process, we got the questions like how to determine the surface area of irregular swimming pools, and by the actions, we use the Simpson rule 1/3.
Hi and Assalamualaikum. My name is Muhammad Akil Afzanim and bin Muhammad Rifin. I'll be presenting this chapter, which is data and calculation. So for calculation, we are using the Simpson's rule method, which is specifically we are using 1/3, which is the multiplication of 2 for the interval value. So as we can see, the step size is 2, therefore we are using Simpson's 1/3 rule, and then the number of steps, there are 12 steps, which is we can get by using the formula, which is n is equal to b minus a divided by h, which is step size. So as the previous slide shown, the surface area, we are going to find the surface area of the swimming pool base, of irregular shape swimming pool base. Therefore we are going to approach it by using iteration method, specifically Simpson's rule 1/3. So for first iteration series, we are going to use the upper side of the swimming pool base, because we divide it by two parts. So there is upper parts and lower parts. So the upper parts will present the upper surface area of swimming pool base, and the lower part will represent the lower part of swimming pool base. So for the upper part, we going to 12 calculation steps of iteration series, and we obtain that the upper part of surface area is equal to 97.16 meters squared. And for the second iteration series, we are going to calculate the second part or lower part of the swimming pool base, which we obtain 124.94 meters squared. So we are, by totaling up the lower part and upper part, we could get the total surface area of swimming pool base. As per the calculation shown in the previous part, we can come to conclusion that the total surface area of the irregular shaped swimming pool is 221.75 meters squared. The iteration series of Simpson rules of 1/3 is used to find the area of the base of swimming pool base surface area. Hence, the actual value can be taken from the features provided in AutoCAD, which is geometry properties. But by performing this method, or we approach to find the actual value by using this method, by using geometry properties specifically, we can find out the actual surface area of swimming pool, no matter how the shape is shaped, as long as it is a closed polygon. So from the calculation that we made and comparison to find the error percentage, we comes out that the relative error is comparison of actual and approximate value obtained from the calculation is 0.1% error. It is proven that the iteration series that we approach is considerably accurate because we are using value function and not using function of equations. So that's all from me. Thank you.